Okay, let's have a look at shear stress and strain. Now the first thing you're going to notice is that it is called shear stress and strain, which is named after a garden tool. Now, why would we name a type of force after a garden tool? Well, if you recall, a compressive force is when you have two arrows pointing towards the body, and tension is when you have two arrows pointing away, which represents the force. And the shear force is where you have two arrows going towards each other, or away from each other, if you want to look at it that way, but they're located at different points instead of going towards or away from each other, which generally causes things to spin. So going back to our garden shear, if you investigate it closely and actually look at it from the front, you notice that there is in fact a shear force. The first, knife or the blade of the shear is heading towards the other blade of the shear, but they're acting in different spots. They're not acting in the same area. So since shear is different to compression and tension, it's denoted with different symbols. So stress is denoted as tau, and the strain is denoted as gamma. So how to compute the shear stress is the exact same as compression and tension. You divide the force over the cross-sectional area. You just need to remember that it is represented as tau. Now, to compute shear strain, it's a little different than the axial, or the amount that the object has elongated. It's the amount that the top half of the object has moved in relation to the bottom half, divided by the height of the object. So if you can imagine you have an extremely tall object and it's moved by about a centimetre, there's not going to be much strain in relation to something which is only a millimetre tall and moves by a centimetre. That's quite a lot of deformation. So there's something called torsion, which is a type of pure shear stress and strain. There is a rotational motion around one end of the object relative to the other. Drills and machine axles are examples of torsion. Shear stress is a function of the applied torque, and the shear strain is related to the angle of twist. So in summary, shear stress is denoted by different symbols to tension and compression, as shear forces behave in separation rather than in unity. Tau is the symbol for stress and is computed the same as tension and compression. And finally, gamma is the symbol for strain and is computed by the displacement of the top point in relation to the lower point over the height of the object. And lastly, torsion is a type of pure shear.